Hello everyone, this is Shanko, and in this video I'm gonna talk about the static keyword in Java. So I'm gonna go through each point and demonstrate each point with code examples. So the first point says that static blocks are executed only once at the time of class loading. For inheritance, static blocks of all the classes are executed as per hierarchy even before the constructors are called. Non-static blocks are called every time the constructor is called. In case of multiple static or non-static blocks are executed in the order in which they are defined in the code. So let's say this with an example, with a code example. So static blocks are executed only once at the time of class loading. So what does this mean? For that I'm going to create a new Java project, simple Java project. And I'm going to call this demo. I'm going to click on finish. It should be small. Right, so let's create a class and let's call it class A, simply A, and let's put it inside package common dot demo. Right, what is the point that we are demonstrating? Static blocks are executed only once at the time of class loading. So let's see what this means. I'm just gonna create a static block and say system.out.println. Inside static block of class A. Alright, I'm gonna create another class inside the same package and call it test, and I'm gonna have a main method inside this class, and let's just create an object of A and see what happens. So A equals new Okay, so let's run this. So it prints inside static block of A. Now let's create another object of A, say A1 equals to new A. See what happens. So it gets printed only once, because no matter how many times we create the object when this class gets loaded, so when this class gets loaded, the static block gets executed, and that happens only once. So no matter how many objects we create of this class, this block gets executed only once. So what is the next line? For inheritance, static blocks of all the classes are executed as per hierarchy even before the constructors are called. So let's see this with example. So say let's create another class. Okay, so let's have a public constructor for this class, public A, and let's just print let's just print inside constructor of class A. Right, so let's create another class and call it B, and let's extend A in this class. Click on finish, and let's have another static block inside this class, and let's print inside static block of class B, and let's have constructor for this class as well. So public B, and let's print inside constructor of class B. Right, let's have one more thing. Let's just have one more static block inside this class, and say let's call this inside static block 1 of class A, and let's call this inside static block 2 of class A. And let's have one more static block for this class as well, and let's say inside static block 2 of class B and inside static block 1 of class B. Now let's do something like AA equals to new B. Okay, let this stay as it is. Let's run this. Okay, so first we see inside static block of class A. So first this gets executed. Then we have inside static block 2 of class A. So this gets executed next. Next we have inside static block 2 of class B. So this gets executed next. Then we have inside static block 1 of class B. So this gets executed next. Then we have inside constructor of class A. So this one gets executed next. Then inside constructor of class B. So this gets executed next. And then we again have inside constructor of class A because we are creating an object of class A here. So the static blocks get executed only once, and the static blocks of all the classes are executed as per hierarchy even before the constructors are called. So before the constructor of this class was called, the static blocks got executed, and then the static blocks of this class got executed, and then the constructor of this class got executed, and then the constructor of this class got executed. So it's like static blocks of parent class, then static blocks of child class, then constructor of parent class, then constructor of child class. So this is the order of execution, and if we have multiple static blocks, then the order in which they are defined inside the class. So this static block is first defined, so this one gets executed first, and then we have this static block, so this gets executed next. So the order of execution is according to the order of description or definition inside the class. So in the order in which they are defined inside the class, in the same order they get executed. So what is the next thing that we have? For non-static blocks, Okay, non-static blocks are called every time the constructor is called. So let's have non-static blocks as well. So let's have a non-static block and say sys out inside non-static block 1 of class A, and let's have another non-static block at the very end and say inside non-static block 2 of class A, and let's just remove this and let's have a non-static block at the very beginning and say inside non-static block 1 of class B, and let's have one before the static block. So let's say inside non-static block 2 of class B. Okay, so let's run this and see what happens. Okay, so first we have inside static block. So the order of execution is like static blocks of parent class, static blocks of child class, then constructor of parent class, then constructor of child class. So one point we need to remember here is every time the constructor is called, the non-static blocks get executed before the constructor, and the order of execution is same as the order of definition inside the class. So first we have the static blocks in the same order in which they are defined inside the class. So we should be having inside static block 1 of class A, and then inside static block 2 of class A, then the static blocks of class B. So inside static block 2 of class B, which is defined first, and then we have inside static block 1 of class B, which is defined next. Then we'll be calling the constructors will be getting called, but before that the non-static blocks would be getting executed. So inside non-static block 1 of class A, so this one inside non-static block 1 of class A, then inside non-static block 2 of class A, so this one inside non-static block 2 of class A, then inside constructor of class A, so this constructor then gets called, and then the constructor of B gets called, but before that the non-static blocks would get executed. So inside non-static block 1 of class B, this one, and then we have inside non-static block 2 of class B, so this one, and finally we have inside constructor of class B, so this gets called. So non-static blocks are called every time the constructor is called. In case of multiple static or non-static blocks, the blocks are executed in the order in which they are defined in the code. Okay, so what is the next point? Outer class cannot be static, same for interface. So let's try to make this static. So we get a compile time exception, and what does it say? Illegal modifier for the class A, only public, abstract, and finder are permitted. So the outer class cannot be static. And same is true for interface. Let's create an interface. Let's call it C, and let's try to make this static. So we again get a compilation error, and it says illegal modifier for the interface C, only public and abstract are permitted. So we cannot have outer interfaces or outer classes as static. Inner class may be static, same for interfaces. Let's see this. So let's have another class inside this class, say public static class, say inner A. So this is allowed. This doesn't give a compilation error. And let's have another interface inside this. So public static interface, say interface C. Again, this is allowed, and this doesn't give a compilation error. So next, what do we have? Static methods cannot be overridden. Static methods get hidden instead. Okay, so okay, let's just delete this interface, and let's have a method inside this class. Let's say public void print message, and let's print printing from class A, and let's have this same method overridden by class B. So let's have it here, and let's say printing from class B, and here we create a type which is of A but whose object is of B. So if we print this, or if we rather call this A dot print message, it should be printing class B. So let's run this. So printing from class B. So this is how overriding works, but let's make this static. When we when we have a variable or a method as static, it gets attached directly to the class. So we need not create an object for calling the variable or for calling the method. We can directly call it a class dot and then name. So static. So now it should be printing inside A, because this is directly attached to the class. So we should ideally be doing like A dot, we can just do A dot print message, because it gets attached to the class. It gets attached to the class, directly to the class. We need not create an object to get the method. So B dot print message. So this should be printing A and this should be printing B. So, yeah. Okay, so what is the next point? Static variables have only one copy in the memory, no matter how many objects of the class exist. Any change in static variable is reflected in all the objects. Static variables cannot be declared inside methods. Alright, first let's see how static variables work. So let's say, okay, just let's get rid of these classes. Alright, just let me get rid of this, and let me just get rid of this. static int x equals 10, and let's create an object of a. Okay, so first let me remove static, and let's create an object of a, and let's print a dot x, and let's create another object of a, and call it a1, and let's print, okay, let's do like a1 dot x equals 20, and let's print a dot x and a1 dot x. So since x is a non-static variable, every object would have its own copy of x. So they should first print 10, and they should again print 10, and they should print 20. Let's run this and see. So we have 10, 10 and 20. Now let's do one thing, let's make this static. So what we saw in the note is that static variables have only one copy in the memory, no matter how many objects of the class exist. Any change in static variable is reflected in all the objects. So let's see how this works. So this should print 10, then a1 dot x equals 20. So since we are changing the value of x, there's only one copy of x in the memory, and it is shared by a and a1. a1 and a, these objects share the same copy of x because it is a static variable, and since we are changing the value, so the value will get changed in all the objects. Yeah, so as expected. Next, what do we have? Static variables cannot be declared inside methods. So this is a method. Now let's try to declare a static variable. Static int y equals say 30. What does it say? It gives a compilation error. It says illegal modifier for parameter y, only final is permitted. So we cannot have static variables declared inside a method. It should always be declared globally. It should always be a member variable. Static variables are always member variables, or declared directly inside a class. It cannot be declared inside a method. So next, what do we have? Static methods or fields can be accessed without creating objects of the class because they are directly attached to the class. We have already seen this, so we can just do without creating any object. We can just do something like a dot x without creating an object. So x is directly attached to the class, so we need not create an object because x is allocated memory at the time of class loading, and its memory space doesn't change, it remains constant. So if we run this, we get 10. Then what do we have to call a non-static member variable inside or method inside a static method? We first need to create an object of the class and then call it by using the object dot variable name. So what does this mean? So let's have say int y equals to 30. Great. So this is a non-static variable, and this is a static method. So if we try to print this directly, we'll get an error. And what does it say? Cannot make a static reference to the non-static field y. This happens because at the time of class loading, this particular method is loaded into the class, but since this is non-static, this is not loaded into the class, and we are trying to fetch this here. So if this is not present, this won't be able to get loaded into the class, into the memory. So we can just access it by doing something like test t equals to new test, and then by using the object that we have created, we can get the variable. And same is true for a method. So if we have something like public void, or say public string message return I, and if we try to print, if we try to call message, we get an error, compilation error. It says cannot make a static reference to the non-static member or non-static method message from the type test. So what we need to do is t dot message. Okay, let's run this. Let's see. So what is the next point? If the inner class is static, the inner class can have static variables and static methods. However, unlike the outer class, if the inner class is non-static, it cannot have non-static variable or method. So let's see the first line first. So if the inner class is static, the inner class can have static variables and static methods. So what does it mean? So let's just get rid of this. And let's do something like public static, say class inner test. So since this inner class is static, we can define, say, static int I equals to 10. We can do this. We can do public static void print. We can do this. So that is what the first line says. If the inner class is static, the inner class can have static variables and static methods. However, unlike the outer class, if the inner class is non-static, it cannot have static variable or method. So let's see if we, okay, so the outer class is non-static, and we can obviously have something like this: static int y equals to 30. So the outer class cannot be static, but we can have static variables, member variables, and static. Static methods. Void, say, test1, but if the inner class is not static, then we cannot have static member variables for the class. The field I cannot be declared static in a non-static inner type unless initialized with a constant expression. And what does this say? The method print cannot be declared static. Static methods can only be declared in a static or top level type. So we cannot do this. Alright. So what is the next point? This is the last one. Abstract methods cannot be static. This is because abstract methods are meant to be overridden, but static methods cannot be overridden. So let's do something like abstract and say abstract static void test1. So we cannot have an abstract method which is static. The abstract method test1 in type test can only set a visibility modifier 1 of public or protected. So abstract methods are meant to be overridden, and static methods, as we have already seen, cannot be overridden because they get hidden. They are actually get directly attached to the class, and they cannot be overridden. So that is why we cannot define an abstract method as static. So that's all for this video. I hope you guys enjoyed this video, and if you did enjoy, please leave a thumbs up, and thanks for watching.